We want to make sure we're pulling that out of the problem. So if you look at A, we have 36x squared minus 16. So first question, is there a GCF? If so, pull it out. That means write it in front, reduce everything, put that part in the parentheses. So is there a GCF with 36 and 16? Got it? It's 4, yeah. So we can divide these by 4. And Gavin, if we pull that 4 out, what do we have left? 9x squared and then minus 4. So then the second thing we want to ask ourselves, is it a special pattern? Gavin, are these special numbers? Yeah, because what makes 9? That's a perfect square. And it's a binomial, so we need a sum and a difference to multiply together to be the negative sign in the middle. So the special pattern for perfect square binomials, we have that sum and difference. So Gavin, what would this look like if we factor it? Nice. So we pulled out the 4, that was the GCF. And then we have a special pattern because they're perfect squares and it's a binomial. So the 4 goes in front, and then 3x plus 2, 3x minus 2. Once you have that set of parentheses, 2 sets of parentheses, that's when you have it factored. You don't have that squared term left in the problem. Letter B, we have 9y squared plus 42y plus 49. So the first question, is there a GCF with 9, 42, and 49? Connor, what do you think? Is there a GCF between 9, 42, and 49? No. 3 looks like it could work, but 3 doesn't go into 49. It goes into 48. So there is not a GCF. Okay, so we check that off. The next part, are these special patterns? Are 9 and 49 special numbers? Melanie? Yeah, they are. So this is that pattern where our answer is just that single quantity squared, and in this case there's a plus in the middle, so there's a plus when we factor it. So this is a special pattern because 9 and 49 are both perfect squares. So Melanie, how would this factor them? So the square root of 9, what times what makes 9? 3. What times what makes 49? 7, and then because this is a plus sign, we place a plus sign in the parentheses and that squared term outside. That really means that we're taking 3y plus 7 times 3y plus 7. That's it. Questions? So both of those were special patterns. If you look at the next one, I'd like you to make one little change. The last number, I believe, initially was a 6. If you can change that last number to a 12. So the first question you ask yourself, is there a GCF? Kenzie Myers, is there a GCF? What is the GCF? 3. Okay, so let's pull out the 3. What do you get when you take out a 3?
5p squared plus 18 minus 4.
Okay. Second question. Mackenzie, are the first number and the last number perfect squares? No. Okay, so we took out a GCF, but they're not perfect squares. 5 and 4 are not perfect squares. 4 is, but 5 is not. So then what do you do if you say no to that question? How would you continue to factor it, Julia? Exactly. So the other type of factoring we have is the AC grouping. So like there's 3 main types. GCF, perfect squares, AC grouping. Like those are kind of the 3 things that you want to think about in your mind and ask yourself little questions as you work through a problem. So AC grouping, this makes a negative 20. Are there 2 numbers that multiply to be 20 that combine to be 8? 10 and negative 2. So 10 and negative 2 multiply to be negative 20. 10 minus 2 combines to be a positive 8. So we're good so far. Next step would be to split it apart. I'm going to ignore the 3 outside for a minute while we work through and just factor this problem. So we have the 5p squared. Gavin said 10 and negative 2. So we're going to place those factors in the middle. So we have 10p and negative 2p, because combine those together we get 8p. We're just writing that 8p a little differently. And then we keep the negative 4. So here's our little scratch work on the side. And we place a little line down the middle. And we want to ask ourselves, what can we pull out? What's the GCF of the left two numbers? So Garrett, what's the GCF of the left two numbers? 5. What else can we take out besides a 5, Garrett? A what? A p, yeah. And what do you have left when you take out a 5p? Yeah. And then how about the second pair of numbers, Garrett? A negative 2. And you still have? And then what's your answer when you pull those together, Garrett?
3.
You're right, good.
Inside the parentheses, 5p minus 2, inside the parentheses, equals.
Awesome. Nice job. So don't forget that 3 that we pulled out initially. We kind of forgot about it as we were working through the factoring steps, that AC grouping stuff. So AC grouping works because when you pull out the GCF, you have this term in between, those two terms in the middle that are the same. So you group the stuff that's outside together and you pull those parentheses together. So that one was the AC grouping method, and GCF. And then the last one on here, we have 25t squared minus 110t plus 121. So first question, is there a GCF? Got some pretty big numbers here, 25, 110, 121. Is there a GCF with those numbers? I don't think so. Especially with the 121. It would be nice if it was 120, but it's 121. So Brandon, if there's not a GCF, what else is going on with these numbers? They are. So 25 and 121 are perfect squares. So how would it factor, Brandon? And then the little square outside. And it's a minus sign because there's a minus sign in the middle there. So 5t minus 11, and then the square outside. Questions on those 4 problems? So 3 of them were perfect squares. 2 of them had a GCF, but that one in letter C, we could factor with the AC grouping. Any questions? So at the top of the next page is just a little reminder of the zero product property, which you had to use to solve those last group of problems, like number 45, the one Mackenzie showed us earlier. So the zero product property just says if you have terms that are being multiplied together, and this is an x, not a p. So x minus p times x minus q, if that's equal to 0, meaning if we have a problem that's factored and it's set equal to 0, you can solve for each one of those factors by splitting them apart and individually setting them equal to 0. That's just a little reminder that it must be equal to 0. That's why it's called the zero product property. So you're taking the product, meaning multiplication, which we get by factoring. You're pulling that product apart, and then you're solving for each one of those pieces. And it has to be equal to 0. It cannot equal anything else. So there's no way you can find x if it's equal to 5 when you're factoring. You've got to use another method. So there is a little word problem on here. And in this word problem, we're making a quilt. I have a nice, pretty, colorful quilt on my board up here. Unfortunately, yours is black and white. But you have made a quilt, rectangular quilt, and the dimensions are 5 feet by 4 feet. Does anybody have sewing? Are you going to make a quilt this year?
Not in school.
No? I think they do, though. Maybe if you take a higher level one. Pretty sure they make quilts like that. I've seen, like if you go to Arts Alive, they have those quilts hanging down with like the squares of like all the t-shirts, like the t-shirt quilt. I'm pretty sure they make quilts. I'll have to ask Mrs. Paslevis. All right, so this quilt is 5 feet by 4 feet. That's what the dimensions are here. I can write in here, let's see here. So we have 5 feet and 4 feet. You can't see mine, but that's what these guys are. You want to use the remaining fabric that you have, which is 10 square feet, to add a decorative border of uniform width to the quilt. And I want to explain this diagram because you'll probably be asked to create your own diagram. So if you look, the extra width that we're adding, this extra border, so this is kind of like a picture frame, but now we have a border that's going around the quilt. So the inside of the quilt that has like all of the t-shirts on it, and then the outside is like a big decorative red border. We're making that to be a uniform width of X. So my inside area is 4 by 5, but the new dimensions would be 5 plus 2X, because the initial width is 5, but we're adding an X on each side because we're adding border to each side. So that's how the 2X part is added onto there. So the initial is 5 feet, but we're adding a distance of X on both sides, and there are 2 spots, a left and a right, so that's how we get the plus 2X. And then the vertical part here, that distance was 4 feet, and again, you're adding border all the way around, so our new distance of this side length would be 4 plus the 2X, because we're adding an X, we're adding an X. You're adding a border on the top, a border on the bottom. And again, that distance is the same, so that's how we get the 2X. So it says, what should the width of the quilt's border be? So we're focusing on the border. In a sense, remember the picture frame problem yesterday. We want to know how wide can this border be with the 10 square feet of fabric that we have. So what's the total amount of fabric we have to use? That's how we would start our equation. Well, that's 10 square feet. That's what it has to be equal to, because that's the extra piece that we need to use to kind of place it around the quilt. How can we figure out, using this information that we have, how do we set up an equation that would be equal to that 10 square feet? So think about area, what you know about area, because 10 square feet, when it's square feet, we're talking about area. What would the area of this quilt be? So how could you look at the area of the quilt? Your end result, Julia?
It's 4 plus 2x times 5 plus 2x.
So the area of the quilt with the border added onto it is going to be 4 plus 2x times 5 plus 2x, because it's the length times the width. That's how we find area. So my new distance, or the new measurement, I should say, of the quilt is going to be all of the 5 plus 2x and all of the 4 plus 2x. But we're only worried about the border part because we already have this quilt made. And the border would be if I could take that quilt art out and then we just have that framing piece left. So if you take out this quilt, the part that you already have made, that area is 4 by 5 feet, or 20 feet. So we have the area of the quilt with the border, because that's what we're trying to find. And then essentially we're taking away that inside part, we're taking away the quilt part. You have to subtract the 20 feet because we don't have enough fabric. We're only looking at the border part, which is the 10 square feet of remaining fabric. So the entire space minus the inside space would be equal to whatever extra fabric that we have that's going to be our decorative border. Questions? So the picture frame problem we set up yesterday was the same thing. We had the entire picture frame minus the inside spot for the picture equal to the amount of material we had to make the frame. So see if you can think, what would you do next? Try and think about, you now have the equation set up. So we have the 10 square feet because that's what we want to make the border out of. We have the area of the quilt with the border, and then we subtracted just the area of the quilt. So what's remaining, if you subtract, should just be that space left over for the border. So how would you continue to solve this problem? What would you have to do? Abby?
You have to make the 10 to the other side.
So we have to take this 10 to the other side. Zero product property says it has to be equal to 0. So that means this is minus 30. What else do you have to do, Abby?
You have to factor.
Yeah, so we gotta FOIL this first, and then we're going to factor it. So we've gotta do the foiling part. And then combine all of your like terms. I'm going to put the 4x squared in the front so that that x squared term is in the front of the problem. So set it equal to 0. Zero product property, it has to be equal to 0 for us to do anything with it in order to factor it. Solve for x. And then also foiling those two quantities together, the length and the width, bless you, of our entire area that the quilt will eventually take up, gives us 4x squared plus 18x, and then when we combine the 20 and the negative 30, we have that minus 10. So we went over 4 factoring examples together as a class. We did 3 more factoring examples from homework, and you got to see 2. So work through like your little check marks in your mind. Is there a GCF? Are they perfect squares? Do you have to do AC grouping? See if you can get this to factor. So a couple of checks in your mind that you're thinking about, little questions. Okay, there is a GCF of 2, so that's the first question to ask yourself. 2 and 5, are they perfect squares? Nope. So if it's not a perfect square, then the only option we have would be to do the AC grouping method. You're using the inside numbers because we took out a 2. So we're using those numbers that are inside. So Tatum, multiplying 2 and 5, we get negative 10. What 2 numbers multiply to be 10, but combined to be 9? Yeah, 10 and negative 1. So when you rewrite it, we have 2x squared plus 10x minus 1x minus 5. So you're taking your 2 factors, you're placing it in the middle of the problem to represent 9 or rewrite 9. And then Tatum, what can we take out of the first pair of numbers here? And inside you get, okay, so if we take not only a 2, but let's take out an x as well, since they both have an x. X plus 5. And then what could you take out of the next pair? Awesome, negative 1. So they also then make x plus 5. So pulling the front terms together, 2x minus 1. The parentheses together, x plus 5, and then that GCF that we took out in the beginning. So if we were just factoring it, this would be our factored answer. 2 and then 2x minus 1, x plus 5. But the question, which mine's way at the top here, says what should the width of the quilt's border be? Because I have 10 square feet of fabric, we want to know how wide to make this quilt look nice. We want to make sure the border's even. So in order to find that, you need to take the parentheses where the x's are, your x terms, and set them equal to 0. That GCF that we took out, if you set it equal to 0, it doesn't have an x term with it. It's not going to give you a solution. And then Odette, if we solve for both of these x terms, we end up getting And which one of those would be a valid solution? The 1/2. -5, we can't have a width of -5. So Odette, what does that 1/2 mean with regards to our width? Yeah, it's a 1/2 foot. You could say it's 6 inches, but that would be the width of the border. So you got this nice quilt, and now it has a nice fancy border to go around it. It's a 1/2 foot in width, or it's 6 inches in width. Questions? So there are 2 quick little problems at the bottom that just ask you to solve. See if you can work through those 2 final problems. Remember, is there a GCF? Make sure it's equal to 0. So A is equal to 0, B is not. Take a GCF out first. So for letter A, if you take a GCF out of 2, we're looking at a -15. You can factor this using AC grouping because you're probably kind of in that method, that form. But if you notice that there's just a 1 in front of x squared, then you don't have to go through the whole grouping process. Because we learned a shortcut to this problem last week. When there's a 1 in front, you can just take these 2 numbers and say x plus 5 and x minus 3. If you don't recognize that, then you can still do the AC grouping. So you can say x squared plus 5x minus 3x minus 15. It's still going to give you that same answer. AC grouping works for every single problem. But there's a shortcut if you notice that it has a 1 in front. So here you should get a -5 and a +3. And then the second one, if you set this equal to 0, we have to subtract 5z and add 4. So that gives a z squared plus 8z plus 16. And asking yourself those 3 questions. Is there a GCF? Are they special numbers? Are these special numbers? Yeah, they actually are because we have a 16 and a 1. So this factors as z plus 4 squared. You could also factor that the AC grouping way because 16 is a pretty small number, so that works with AC grouping. So the worksheet that I gave you, on the front, you're doing that bottom section, 42 to 60 even. And then on the back of this worksheet, you're doing the kind of the bottom 3 sections, 22 to 48 even. And the back, like the back of the worksheet, section 10.5 are the special patterns. The front of the worksheet would be the AC grouping. Please do these on a separate piece of paper. Tomorrow we're going to just kind of review factoring those 3 different questions to ask yourself. Have an awesome day.